Learning goal today says I can write a linear equation in slope-intercept form. So far we've talked about only one form of a linear equation, and that is standard form. Can you give me what standard form is? What does it look like when a linear equation is in standard form?
Ax plus by equals m.
Not m, but capital C. So capital AX plus capital BY equals capital C. X's and Y's are together on the same side of the equation, and the constant is on the other side by itself. What is that? When it's in that form, it's actually very user-friendly if we want to find the X and Y intercepts. So that's when we worked with it in standard form. Now we're going to start talking about another form. So that same equation written in standard form can also be written in slope-intercept form. Still the same line on the graph, still has all the same ordered pairs, it just has a different name is all. And so when it's in slope-intercept form, the reason why we like slope-intercept form is because it's graphing friendly then. So what is the slope-intercept form of a linear equation? How does it go? Not ax plus by equals c, because that's already been reserved for standard form. Lindsay?
Y equals mx plus b.
Yeah, y equals mx plus b. So in other words, when the equation is solved for y, we can say that it is now in slope-intercept form. So what is the slope in that equation? What did you learn when you were SQ3R? Which of those variables is representing slope? Austin? M. So what x is being multiplied by, the m value, is considered to be the slope. What's considered to be the y-intercept then in that form? We got all those variables. M's already been spoken for. You can't take that one. Haley?
B.
B. Yeah, B is the y-intercept. So we can count on that when it is in slope-intercept form, we can just look at that equation and be able to tell what the slope of the line is and what the y-intercept is. What's the y-intercept mean again? What is that? Maybe I should have failed you all first semester. Huh? Benton.
Where the line intercepts the vertical axis.
Yeah, where the line intercepts the vertical axis, also known as the y-axis. So that point where the line crosses the y-axis is considered the y-intercept. Okay, so let's practice writing the equation that describes each of these lines, but we want them in slope-intercept form. And it's going to be pretty painless, really, because what we do is we just write down what would the 5 represent? What would that be? That's our m value. And what's the -1 represent? That's our b value, isn't it? So we can just write y equals 5x plus -1. We're replacing the m with our 5 because that's what it's standing in there for. We replace the b with -1 because that's what the b is standing in there for. And then we would clean this up because how would it actually look in an answer bank? They're not going to have this plus a negative. We would clean it up, and this is how we would see it in an answer bank. Y equals 5x minus 1. Okay, you try the next one. Write the equation of a line that has a slope of -1/2 and a y-intercept of 0. Who wants to offer up while they wrote it? Benton.
Y equals -1/2 x.
Like that? Okay. Anybody want to agree with that? Okay. Does it start like this? Yeah. So why did Benton leave that off? Or Benton, why did you leave that off?
Because adding 0 is doing nothing to the equation.
Yeah. Adding 0 is not changing the equation at all. So again, we always clean it up. We would never see this equation written like this in an answer bank. We would see it written as Benton gave it in the first place. y equals negative 1/2 x. So that is not saying that does not have a y-intercept. It is saying that the y-intercept is at 0. Where's that at? What famous point is that? If the y-intercept is 0, where's it crossing? At the origin, yeah. Oh, well, this kind of equation should look familiar. What special linear equation is this? This is a what? We just covered this in the last lesson. It's a two-part thing. It's a what? A direct variation. Yeah, this is a direct variation with our k value being what? Negative 1/2. So are you starting to see that k and m are really the same things? They both represent slopes. They call it k when it's in a direct variation. They call it m when it's in just a linear relationship that is not direct variation. It would have been nice if they just would have kept them both the same. Okay. How about the next one? What would we do with this one? So that's how we're going to see that one in an answer bank. Just by substituting in, what would we have? Y equals
4.
Yeah. After it's cleaned up. When we're substituting in, would we do this? 0 is going to go in for m. 4 is going to go in for b. But of course, that's not how we're going to see it in an answer bank, because 0 times anything is 0 times anything is 0, and 0 plus 4 is 4. So we would clean this up and say it is y equals 4. Okay, let's do just a quick, because I need you to start making this connection also. What kind of a line has a slope of 0? This is what kind of a line? This is a horizontal line. Yeah, let's just draw a little sketch of that to show you. We have a horizontal line here. Because this is what's going to happen. When you do not have an x term in your linear equation, that means you have a horizontal line. When you do not have, so you have this equation in slope-intercept form, even though the 0x is missing, it came from 0x plus 4. When you have no x's, that means the slope was 0, which then means you're going to have a horizontal line, because horizontal lines have a slope of 0. So we can count on that when we see an equation y equals just a constant, you better be ready to just immediately say, you know what, I have a horizontal line here. Any questions on being able to write the equation from substituting in the slope that they gave you and the y-intercept that they gave you? Should you clean them up, do you think? Yeah, that's how you're going to see them in an answer bank. So like that final that you took yesterday, when you have those multiple choice answers, they're not going to have the choice as y equals 0x plus 4. They're going to have it as y equals 4. And you have to understand that that can be the same as y equals 0x plus 4. Okay, let's go to this next section. In this section, we're identifying the slope and the y-intercept for each function. In other words, they give us the equation this time, and now we're going to pick out the slope and the y-intercept from the equation. So if it is solved for y, such as number 4 is, it's solved for y, it has y alone. It is in slope-intercept form. And what did they do? I want to kind of like unclean it up, I want to call it, if there is such a thing. I want to take it back to where was it before they cleaned it up? It's negative x. What's that the same as? Negative 1x. Yeah, they cleaned it up and said, you know what? You don't need to leave that 1 in there. And then plus 3. So in reality, this is what it started as, but then it got cleaned up to negative x plus 3. So what is our slope? Negative 1. It's what x is being multiplied by. It's what's in the m place. And what's our y-intercept? 3. So basically we're saying here, m equals negative 1, b equals 3. Okay, go ahead and do the next one. So they're giving you the equation already. Notice I arrowed over because I'm thinking that's been cleaned up. That's its name after it got cleaned up. So what did it look like before it did? Might be helpful. Okay, can somebody tell me what this looked like before it got cleaned up? Any? Yeah, this is how it looked before it got cleaned up. Y equals 0x plus negative 2. So the slope is 0, right? And the y-intercept is negative 2. What kind of a line is this? It's a horizontal line, isn't it? Yeah. How about that line in number 4? If we graphed it, tell me what would the behavior of that line be? Number 4's line. What would its behavior be? Remember, there are 4 behaviors because there are 4 different types of slope. So you just told me the behavior of number 5 is the horizontal line. Benton?
Number 4 would be negative slope.
Okay, so what's its behavior then? What does that mean?
Goes down from left to right.
It falls from left to right. So we would expect on a graph. Now, the reason I'm going to just keep pounding this into your head is because we're going to do a lot of graphing. And even on I remember the 4.1 to 4.5 quiz, I was rather surprised that when they gave some of, all of us did the same problem, but some of you did not keep in mind what I told you to. If the line is falling from left to right, you better end up with a negative slope. There were lots of people ended up with a positive slope for that problem. The line was falling from left to right, and I was like, oh, I guess they forgot to ask themselves that question. Should the line, I can see the behavior of the line, what kind of slope should I get? Okay, how about number 6? Do you think that's been cleaned up? What do you feel about that one? Do you think that got cleaned up from something? Yeah, because slope-intercept form is y equals mx plus b. So does this have a plus in it? No. So this really did get cleaned up. It was like this before. Y equals 1/4 x plus negative 5. And why do I make such a big deal out of that? Well, because some of us will make the mistake of identifying the y-intercept wrong. So what is our slope? We'll call it m. M equals what? 1/4. So what's the behavior of this line? That's the type of slope. What's its behavior? Rising from left to right. If we had to graph it, this better be rising from left to right. And what's its b value, also known as the y-intercept? Negative 5, which tells us what about the line? What's it going to do? What's it going to do? That negative 5 tells us something too. What is this line? If I graph this equation, okay, it's going to start at, or not even necessarily, that's when we are graphing it, that would probably be our starting point. But in reality, there are lots of points you can start with. So we would say this is where we can count on the line crossing the y-axis at ordered pair 0, negative 5. That's where it would cross the y-axis. Okay, let's go to the back side and see what we're going to practice back there. Not always do they give you the equation in slope-intercept form. Remember I said slope-intercept form is handy for graphing because we can pick the slope out of it immediately and we can pick the y-intercept out of it immediately. But what if they give us the equation in standard form? And you are told to put it in slope-intercept form. That would mean you better get it solved for y. In other words, get y alone. Now, this is like what we were practicing back in chapter 1, solving the equation for a different variable. Right now, it's not even solved for a variable, it's solved for a constant. So what would we do first to get y alone? Subtract 8x. So we subtract 8x from both sides. I remember this not going so well for some of us. 2y is alone now. Can you really take 8x away from 6? Can you combine them? Are they like terms? No, they're not. So we have to leave it like this. And I'm going to actually change it to add the opposite. 6 plus a negative 8x. Because now what's our next move? What do we have to do? Divide every piece by 2. Not just the ones that you think look friendly, Some of us just divide the ones that, you know what, that looks like it'll work, so I think I'll do that one. Every piece has to be divided by that 2. So now we have a single y like we want. 6 divided by 2 is 3. A negative divided by a positive is a negative. And 8 divided by 2 is 4. And remember, when there's an x in the numerator, it can just come out beside the fraction. And so if that one becomes a negative 4x. In an answer bank, how do you think that's going to look? In a slope-intercept form, cleaned up. What's going to look like cleaned up in an answer bank? What do you think? Lindsay?
Y equals negative 4x plus 3.
Yeah, that's what they would do with this one. They would make it negative 4x plus 3. Which then now helps us be able to identify the slope and the y-intercept. We couldn't do it when it was in standard form, but now we can. What is the slope of this line? Negative 4. What's the y-intercept of this line? 3. What's the behavior of this line? Falling from left to right, falling on the graph from left to right. And where's it crossing the y-axis? At 3, yeah. Okay, go ahead and do number 8. Let's get that one into slope-intercept form. Again, for many of us, it'll be helpful if we rename it first in its not cleaned up state. Others, maybe you can do it without. But we're going to do a lot of this, and you got to get good at it. You got to get really good at it. What needs to be alone? The y. The y's have to be alone, and not only can it just stop when the y's alone, it has to become a 1y, doesn't it? Okay, what's the answer for this one? What's the slope-intercept form? Okay, y equals 1.2x, or no, 0.2, okay? So we could give it that way, or what? Here's the way I want you to give it. Because 0.2 isn't going to be very friendly when we start graphing. So what can we do when we have a negative 1 divided by a negative 5? Instead of giving it its decimal name, leave it as a fraction. And a negative divided by a negative is a positive. So we are going to be better off if we leave it. I'm not saying that you cannot put it as 0.2, but I'm just going to say that that's probably not going to be very helpful for graphing. So we're going to make it 1/5 x. What's negative 10 divided by negative 5? 2. And now over here we have our y alone. But of course, in an answer bank, they would have the x's and the constant trade sides. Trade places, I mean, not sides, trade places. So the equation should be y equals 1/5 x plus 2. Do you agree?
Yeah.
Behavior of this line. Rising from left to right, doing what? Don't just do these. So you've decided it's rising because it has a, you got to identify the slope and y-intercept yet, by the way. M equals 1/5. That makes it rise from left to right. Is it very steep, by the way? What do you think? Would this be a very steep line?
No.
There's a rise of 1 unit and a run of 5. So do you think that's going to make for a very steep line? No. If it rose 5 and only ran 1, would that go steeper?
Yes.
So this is rising from left to right, not very steep probably. And what else is it doing? You need to do this every time you find these. You need to visualize what would this do on the graph? Caleb, what's it going to do besides rise from left to right with not a whole lot of steepness? It is going to go through the x-axis, but do we know where? Does this give us any information about where it's going to go through the x-axis? No. We can identify a b value, and that b value is where it's going to what? Cross the y-axis. So it's going to cross the y-axis at 2. So here are the pieces we needed, and that's what will help us be able. We're not going to do. You should have been doing some graphing in your SQ3Rs. Today we're not going to do any graphing. Tomorrow we'll get into the graphing part. Okay? Any questions? Just because you don't have to graph today, though, do not just be happy to have a numerical answer. Say to yourself, this is what I think the behavior of the line will be. This is where we cross the y-axis. What would I see on the graph?